Hi everybody, this is your geography lesson on climate change for the week beginning the 8th of June, and you are being asked to complete this work for the end of this week, Friday the 12th of June. Okay, the first thing you have to do obviously is watch the lesson video which you are currently watching, and that's can also be accessed through this link here. And the first part of today's lesson video will actually help you deal with this first task number 1. Other thing you need to have opened is this document here, which is called Climate Change Number 2. And that's where I want to start with today, okay? So the first thing you should do is scroll down this page and read what is on this page, okay? And then what you're going to be asked to do is answer the question at the bottom of this page, okay? So what the two questions are, let me just show you what those questions are. The first one is to use the pie chart to describe the different proportions of greenhouse gases found in the atmosphere. And then the second question is to tell me why carbon dioxide is by far the most common greenhouse gas after water found in the atmosphere. Why should we be even more worried about changes in the amount of other greenhouse gases? And in brackets, use the table. Now, both of these questions are just to use information from the table. And the first one is very straightforward. Describe question asks you to describe what you can see in a pie chart. Okay, now in this pie chart we can see, once we take water vapor out of it, because that is the dominant greenhouse gas, some very simple information that of all greenhouse gases, carbon dioxide is the most common. And rather than tell me why it's the most common, because that's not what you're being asked to do, you're just being asked to describe what you can see. You just need to tell me that carbon dioxide is the most common gas in the atmosphere, with 84% of all greenhouse gases being carbon dioxide. What you then do is you then tell me about the other three. Now, what you're being introduced to here for the first time are these gases up here called the fluorinated gases, or for short, we just call them the, okay? And whilst they seem like a very small amount, I'm going to shortly be showing you how bad these gases are. But in your description, you should describe the proportions of all four. Generally, when you describe a graph, even to the pie chart, you must use the data that we can see here. You must refer to the specific thing you're talking about, and you generally start with the largest first, and then you move your way down to the smallest. Okay. Now that would answer your first task of greenhouse gases, because what you will remember from last week's lesson is that greenhouse gases are influence the greenhouse effect, and if you have too many greenhouse gases in the atmosphere, it causes a problem known as global warming. And you have also established that the amount of carbon dioxide in the atmosphere has been increasing also last week. Now let's have a little look at this graph. This is going to help you answer the second question. So we can see from the pie chart that carbon dioxide is the one that we should be most worried about, because it's the most common 4% of the greenhouse gases in the atmosphere. And I say greenhouse gases, I don't mean gases, I just mean the greenhouse gases. They are just some of the many gases you find in the atmosphere. So for example, you also find oxygen up there, but oxygen is not a greenhouse gas. Oxygen does not cause the planet to warm up or cool down. So carbon dioxide is the most common, and we get here on the table, but it's actually maybe not the one we should be most worried about. And here's why, okay? Because whilst it is the most common, it actually doesn't have the same amount of global warming potential, okay? What we can see here is that methane has 23 times more global warming potential over a 100-year period than carbon dioxide, because carbon dioxide has a global warming potential of 1. So let's just, for argument's sake, say 1 molecule of carbon dioxide could heat the planet by a certain amount. That same molecule of methane, so we just have 1 molecule of methane, can have 23 times the effect. So you need 23 dioxide molecule of methane. So we worried about methane? Okay, it's only percent. We should be worried. It's 23 times more powerful. Okay, now why should we be worried about the other ones? Well, nitrous oxide, which might only make 4% of the greenhouse gases in the atmosphere, is 296 times more potent. It has 296 times more potential than 1 unit of carbon dioxide. So we would need 296 molecules of carbon dioxide to equal the same power of nitrous oxide. And then it gets really worrying. Then we get to these two. Now, these two are both F gases, perfluoromethane and sulfur hexafluoride. Okay, so they're both part of this tiny 2% up here. But you can see the CF4, that's just the short chemical name for this gas, is 5,700 times more powerful than carbon dioxide. And sulfur hexafluoride, or SF6 as it's known, it's really bad. It's 22,000 times more powerful. Now, there are other reasons to also be worried about the other 3 greenhouse gases over and above carbon dioxide. And that's because they last in the atmosphere quite a long time, especially if you have a look at this one, CF4, it can survive in the atmosphere for 50,000 years. Okay, and we also can see its cousin, sulfur hexafluoride, can last for 3,200 years. So whilst carbon dioxide can remain in the atmosphere for anywhere between 50 to 200 years, which is worrying because that's a long time, these F gases, because they last so long, they will be damaging or they will be warming the planet a long, long time in the future. So we don't want to see too much of an increase in these two gases. Okay, so what I did is I just talked you through this column of data here and how it explains to us that we should be worried about other gases other than just carbon dioxide. And I also talk about this column here about how long some gases last in the atmosphere, and that's also why we should be worried. You want to use some evidence from this table to answer the second question. Okay, so what I'd like you to do is just finish this now, and I will come back to some other tutorials later on, and you'll find them linked, that will help you answer the rest of the tasks. But if we just take a quick little journey through what remains of today's lesson, you've got 3 more questions, and we're just going to scroll down. On the second page, it's all about evidence of climate change. How can we prove what the climate was like thousands of years ago? How do we actually know changes? And there are 3 bits of evidence, and I've also got 3 videos for this task, which I'm just going to show you. So if I just scroll down a little bit, you'll see here they are. You've got a video on ice cores right there. You've got a video on tree rings right there. You've got a video on the Arctic ice. Please watch each of these. Once you've watched them, could you then read the page on the evidence of climate change as you're asked to do? And that will then take you on to task number 3, where you need to watch this video on how volcanic eruptions can influence the climate. Now, one of the things you've got to be very careful with the word climate change, and this is the first time I've introduced you to this quite important piece of knowledge, is climate change and global warming are 2 very different things. Climate change just means the climate is changing. That can be going up, that's global warming, if it's warming, or going down, and that's global cooling, and we often call that an ice age. Now, as you're going to discover with volcanoes, when you've watched this video, the volcanoes are actually responsible for global cooling, and you'll be able to do watch the video. You'll be able to explain that that's the case. The second one is more to do with how ocean currents. Last task, a video will talk to you about how ocean currents influence the climate of different parts of the planet, and how ocean currents move water around and affect the air temperature of the water. So, for example, if it wasn't for ocean currents, the heat in the equator would never get to the northern areas of the world. And we in the United Kingdom, for example, we're heated by an ocean current that comes across the Atlantic called the North Atlantic Current, or sometimes it's the Gulf Stream, and it brings water from the Gulf of Mexico, warm water, that brushes past the west coast of the United Kingdom, and with that there comes warmer air. So if it wasn't for that ocean current, Britain would actually be as cold as northern Siberia in Russia. So ocean currents have a huge influence over the climate of different areas. Your job is to watch this video, explain that. Just to finish off with, when you do actually look at the questions that go with that, you'll notice there are 3 marks for both of these questions. So let me just scroll to the end. So please, there you are. There's the volcanic eruptions. You've got a little bit of reading to do. You've then got to explain in as much detail as you can think of on how volcanoes influence climate change. You might want to talk about Mount Pinatubo, which appears in the video, and give other facts and information about sulfates and so on, and how all of this influences the climate of the planet. And you then do the same question number 2, which is on ocean currents. Okay, and that is your work for this week. So hand it in by Friday, and good luck.